Welcome back, dear students. This is Ramana sir, physics. How are you all? In IPA, most important questions asking maximum students. Why? Because the maximum my students, the 60 by 60 scored in IPA examination. In last 20 years, every year they are getting 60 by 60 in IP examination by following simple logics in very short questions and short answers and long answers. So they are following very easy methods. They are learning very easy these topics and they are getting 60 by 60 in physics. So that is why maximum students requested to me make the videos for IP examination also. So that is why I am explaining the IP important questions also. In this class, most important question in first year IP examination, both TS and AP, that is simple pendulum. If you ask any your seniors, they'll say only one thing. The most important question in first year physics means they'll tell simple pendulum is most important. So that much important this topic, simple pendulum. Here the last question, show that the motion of a simple pendulum is simple harmonic motion and hence derive the equation for its time period. And they'll ask what is seconds pendulum also. In this class we'll discuss the simple pendulum topic. What is simple pendulum? In this, after solving this answer, after deriving the time period of the simple pendulum, so they may ask the problem also, attachment problem. You know that physics long answers means attachment problems they can ask. Sometimes they can ask, sometimes any definition they'll give. So anyway, so all types after long answer, so what they'll ask, the problem or any definition or any, so previous question what they asked, so that all will discuss in this class. Okay, so let's start the class. So first of all, what is simple pendulum? Simple pendulum means here observe, heavier mass of the body is suspended with help of massless string, very light mass, very light string, like so massless string, inextensible, it should not extend, the thread should not extend, and this is very light mass. So one end of the string is connected to a rigid support, say S, and other end one heavier mass of the body like metallic ball is attached here. That ball is called bob, B-O-B, bob we can say. So that is metallic bob. So such pendulum is suspended with help of rigid support, fixed support. This is called simple pendulum. Simple pendulum means a heavier mass of the body is suspended with help of massless string. With help of massless string is called simple pendulum. Now the pendulum is pulled aside, then release. What happens? We'll see. Now the pendulum is pulled aside. What happened? Through small angular displacement. That angular displacement say theta. Here at this position, for example, this is starting position, mean position is O, and extreme position is say A. At extreme position, what happened? Weight of the body acts vertically downward, that is mg. Weight of the body acts vertically downward, that is mg. Here tension in the string acts vertically upward, say T. This weight mg is resolved into two rectangular components. One is balanced by tension, that is mg cos theta, and another one is say mg sin theta, mg cos theta and mg sin theta. So here take angle theta. You can observe here the tension in the string is balanced by mg cos theta and our applied force is balanced by what? Force F. Our applied force F is balanced by mg sin theta. So I hope understood here. Here the theory part I'll give in the screen, so you can take that one. So what to write? Listen, very simple method you can write. What to write? Okay, listen here. Consider a metallic bob is suspended with help of massless string. Okay, that string length is what? L. So this is called what? Simple pendulum. A heavier mass of the body suspended with help of inextensible and massless string is called simple pendulum. The length of the pendulum is what? L. So where to where we have to take? From point of suspension to center of the bob. So that is simple pendulum length. Now the bob is pulled aside through small angular displacement theta. Then release this body. What happens that time? It starts to and fro oscillations. And at one of the extreme position, the weight of the body acts vertically downward, that is mg. And this mg is resolving into two rectangular components. One is mg cos theta, another one is mg sin theta. This mg cos theta is balanced by tension T, and this mg sin theta is balanced by applying force F. So this matter as it is you can write. After the matter, equations are most important. So listen carefully. Here what I am saying, the applied force is balanced by mg sin theta. Here F is balanced by what? Mg sin theta, that is minus mg sin theta taking. Substitute here, but F equal to what? Ma. Substitute here, Ma equal to what? Minus mg sin theta. Gets cancel. A equal to what? Minus g sin theta. I am taking only theta. I am taking. Why? Because okay, theta only I am taking. Since I am writing theta is very small. Theta is very small. That is why sin theta nearly equal to what? Just theta only. Sin theta nearly equal to what? Theta only we can take. Now A equal to minus g theta we got. So from figure you can observe. From figure you can observe angle theta equal to arc by radius. Here arc is what? This displacement you take x. The displacement how much you are taking? X we are taking. From figure angle equal to angle theta equal to what? Arc. Arc is what? L by radius. Arc is what? Arc is x by radius. Radius is nothing but L, the length of the pendulum. Now here theta equal to what we got? X by L. Theta equal to x by L. Substitute in this equation 1. Equation 1 implies what happens? Theta equal to A equal to minus g into theta is what? X by L. Here A equal to what? Minus g by L into x. Say equation 2. Equation 2. This A equal to acceleration equal to minus g by L into x. So generally in simple harmonic motion the acceleration is directly proportional to displacement in negative. Here apply here, compare this one, but in SHM, in simple harmonic motion acceleration is equal to what? Minus omega square x. Say equation 3. Compare equation 2 and 3. Comparing equations 2 and 3. Here instead of A is there, equal symbol is there, minus is there, x is there. But instead of omega square, what is there? G by L is there. Omega square equal to what? G by L. Omega equal to what? Under root G by L. Omega equal to what? Under root G by L. Here we concluded. So this is okay. The motion of simple pendulum is simple harmonic motion. You can write here. Therefore, motion of simple pendulum is simple harmonic motion. Motion of a pendulum is simple harmonic motion. We proved this one. Motion of simple harmonic motion is what? Simple pendulum is simple harmonic motion. Comparing time, what we got? Omega square equal to G by L. Omega equal to what? Under root G by L. In time period formula is what? time period formula T equal to 2 pi by omega. In angular motion, time period formula T equal to 2 pi by omega. Substitute here T equal to 2 pi by omega. How much we got? Under root G by L. Under root G by L. Therefore, T equal to what? So this sent to numerator, what happened? 2 pi into here under root G by L becomes under root L by G. G by L become L by G. So therefore, the time period of simple pendulum is what? T equal to 2 pi into under root L by G. So this is the time period derivation for simple pendulum by very easy method. Very easy method. Addition to this, they can ask what is seconds pendulum. Seconds pendulum is a pendulum whose time period is 2 seconds. A pendulum whose time period is 2 seconds is called seconds pendulum. Then simply you can write a pendulum whose time period is 2 seconds. 2 seconds called seconds pendulum. Seconds pendulum. Therefore, T equal to how much? Seconds pendulum? 2 seconds. T equal to how much? Seconds pendulum. So this is the simple pendulum derivation. If not understood, so you can check one more time. A very easy method. Easily you can get the 8 marks by writing the seconds pendulum definition also. And another any numerical is given. So that numerical also I'll discuss in this class only. So attachment. Sometimes they can ask the numerical. 6 marks plus 2 marks, 8 marks. Sometimes they won't ask, only seconds pendulum definition they'll ask. So that time also they can give the 8 marks. By following these steps along with neat diagram, first matter, very easy matter, whatever I said, that matter you write own words and draw the neat diagram, and these clear steps, the equations very clearly, if you write these steps, you'll get the 8 by 8 marks. Okay, so we'll continue the next question, simple harmonic motion. Another question is there in this lesson. 2 questions are there in oscillation lesson. Anyone compulsory either simple pendulum or simple harmonic motion. Motion of a particle on the circumference of the circle is simple harmonic motion. Another question also there, that also now I'll discuss. Then I'll discuss the numericals also. The second LAQ from this lesson, oscillation. First simple pendulum, another one is simple harmonic motion. In this question, they can ask what is simple harmonic motion. First definition they'll ask. After definition they'll ask, show that the motion of a projection of particle performing uniform circular motion in any diameter is simple harmonic. Okay, in this question they can ask definition also, and the particle motion we should explain as simple harmonic motion. We have to show that on any diameter. Okay, particle of motion on any diameter is simple harmonic motion. We have to prove that one. So first of all, definition. Simple harmonic definition already we discussed. What is simple harmonic motion definition? A body said to be in simple harmonic motion means the body should move to and fro oscillations, and the acceleration of the body is always directly proportional to the displacement. Directly proportional displacement in opposite direction. So the acceleration of the body always towards the mean position, towards the fixed point. So that is called simple harmonic motion. Okay, what is the definition? The body should move to and fro oscillations, and the acceleration of the body is directly proportional to the displacement in opposite direction. Acceleration and displacement should be in opposite direction. So this body always towards the fixed point, that is called simple harmonic motion. Then we have to prove this case. What is the case? Show that the motion of a projection of a particle performing uniform circular motion on any diameter is simple harmonic. In this, some differentiation part will come. So very simply we can remember that formulas by PC students. So don't worry, by simply, so you can remember the formulas by two formulas. If you remember, so you can solve this answer very easily. So listen here, the matter, own matter, here also you can write. So I'll give on screen also, I'll give the matter. So very simple matter. Listen here how I am explaining. Same matter you can write in your own words. Listen here. So consider a particle on your x dash and y dash, two perpendicular axes are there, diameters are there on the circle. X dash and y dash, two perpendicular diameters are there. So on x dash, for example, a particle is there. The particle is moved, okay, so and reached at point P. The particle is reached to at point P through small angular displacement, say theta, with angular velocity omega. The particle is moved through angular velocity omega to small displacement, angular displacement theta. Understood? Now, so from P point to on y dash, I am drawing one perpendicular line. So that on that line I am taking that point is say N. This Pn is a perpendicular on y dash diameter. Now this O to N, origin to this N distance I am taking. This distance I am taking, small y I am taking. On y dash axis, the displacement I am taking small y. Here we know that angular velocity means what? The rate of change of angular displacement. D theta by dt, simply theta by t. Theta equal to what? Omega into t. Theta equal to what? Omega into t. So here instead of theta we can write omega into t. Omega into t we can write. So this opposite angles, this is theta, means this one also theta. So that also we can take omega into t we can write. So from figure you can observe when the particle is moving on the circle, so what happened that time? So this N also move on this diameter. From figure you can observe O and P. From O and P, from figure, matter how I explain, so you can write that one. So otherwise on screen also I'll display the matter. So matter, just matter, 4-5 lines matter you write, then you can start the derivation. From figure, draw the neat diagram. After the diagram, explanation part, just you write. From figure, O and P. Here sin theta equal to what we can take? Opposite side by hypotenuse, so that is OP. Here hypotenuse OP. OP is what? Radius of this circle. The radius we can take A, we can take, that is maximum displacement amplitude. Maximum displacement amplitude will take, that is capital A I am taking. Radius of this circle, capital A I am taking. Here sin theta equal to what we can take in? Opposite side by hypotenuse. Opposite side is ON. Hypotenuse is what? OP. Now ON equal to what? OP into sin theta. OP into sin theta. Here theta is what? Omega into t. ON is what? The on y dash axis ON. What is the displacement? Small y. Small y equal to OP. OP is what? The radius A, and sin theta. Theta is what? Omega into t. Y equal to A sin omega t. So this is a displacement formula in simple harmonic motion. Displacement formula, this one. Displacement formula we got. Now velocity I want to find. How to find the velocity? We know that the rate of change of displacement is velocity. Velocity I want to find now. Velocity V equal to velocity v equal to what? The rate of change of displacement dy by dt we can take. V equal to d by dt of y. Y is what? A sin omega t. A sin omega t. Here A is constant, writing outside. A is constant, writing outside. V equal to d by dt of sin omega t. Sin omega t formula is what? Differentiation. BPC students, MPC students can easy this one. Differentiation formulas. But BPC students, remember this one. D by dt of sin theta is cos theta. Okay. Here A constant, right outside only. D by dt of sin theta is what? Cos theta. Here instead of theta, omega t is there. Omega t. And into omega we have to write here additional what is there into omega t is there, so that is again differentiation of d by dt of omega t, we get omega. So don't confuse. V equal to how much? A omega cos omega t. This is velocity equation we got. Now acceleration will find. Acceleration is what? The rate of change of velocity. The rate of change of velocity is called acceleration. Acceleration A equal to d by dt of velocity. V value how much is there? A omega cos omega t. A omega cos omega t. Substitute here. A omega is constant, right outside. D by dt of remaining is what? Cos omega t. Remaining cos omega t. Here A equal to, here A omega as it is, cos omega t. Differentiation of cos omega t is what? Minus sin omega t. Here sin time, differentiation of sin time, cos theta we got. Differentiation of cos time minus sin theta will get. Into again omega t is there na differentiation, into omega will come. Here write minus outside. A equal to minus outside A omega square sin omega t. So this A I'll write here, this omega into omega, I am writing omega square A sin omega t. We know that A sin omega t from displacement formula, A sin omega t is what? Y. Therefore A equal to what? Minus omega square y. Since I'll write y equal to A sin omega t. A sin omega t I'll write. A equal to what? Minus omega square y. Here this omega square is constant, means therefore A is directly proportional to what? Minus y. A is directly proportional to what? Minus y. That meaning is what? The acceleration of the body is directly proportional to the displacement in opposite direction. So that is, the body is in simple harmonic motion. Simple harmonic motion formula is what? A equal to minus omega square x or y. Here we proved A equal to minus omega square y. And acceleration is directly proportional to the negative displacement. So hence, the motion of a projection of a particle performing uniform circular motion on any diameter is simple harmonic motion. Why? Because therefore this equation represents what? Simple harmonic motion. So that conclusion you have to write finally. So you will get the 8 marks. Sometimes they can ask problem, attachment problem, very rare cases. Attachment problem also they can ask. So that simple pendulum and this simple harmonic motion second topic, these two questions. Now numericals also I'll explain. Don't skip the video. So if you solve these problems, then only you'll get the 8 marks. Okay, so don't skip the video. Very easy problems by easy steps. If you remember same problems they are repeating, if you remember you'll get the 8 by 8 marks. Okay, here one question is asking a simple pendulum or simple harmonic motion attachment. Maximum for simple pendulum they can ask the this problem, this type of problems. Check once. What is the length of a simple pendulum which takes seconds? Which takes seconds. That is nothing but the time period is 2 seconds. Seconds pendulum. They are saying indirectly seconds pendulum. Seconds pendulum time period is how much? 2 seconds. The simple pendulum derivation, after the time period derivation we observed seconds pendulum definition. The time period of seconds pendulum is how much? 2 seconds. Here, first of all, any problem in very short question or long answer attachment questions, first of all given data we have to write. Here the given, what they given indirectly which takes seconds they are saying means time period is given. So time period is for seconds pendulum is how much? 2 seconds. Since I am writing this is seconds pendulum, how much I am taking? 2 seconds I am taking. Here the length they are asking, L value they are asking, length of the pendulum how much they are asking. We know that from simple pendulum time period formula, from simple pendulum time period formula, what is the formula? Just now we derived simple pendulum time period formula. T equal to, what is the formula? 2 pi into under root L by G. T equal to 2 pi into under root L by G. Here squaring on both the sides. Squaring on both the sides. T square equal to what? Here 2 pi is there. 2 square is 4. Pi square. Pi square. And squaring time under root L by G. Squaring time what happens? Square and root gets cancelled. L by G will get. Don't confuse here. Squaring on both the sides. Here T square. Here 2 square is 4. Here pi square. And root L by G whole square is what? L by G. Now we need to calculate L value. So L takes subject. L equal to what happens? G into T square by this 4 pi square is multiplying. If I send this side, what happened? It divides 4 pi square. That equal to G value. How much here? Not given in question. That is why 9.8 meter per second square. G value is not given. How much you have to take? 9.8 meter per second square you have to take into T square. T value 2 seconds na? 2 seconds whole square divided by 4 pi square. 4 into pi value how much? 22 by 7, that is 3.14 whole square. 3.14 whole square. Here 9.8 into 2 square is how much? 4, and 4 into 3.14 whole square. 3.14 into 3.14. Solve this one, you'll get 9.86. You'll get here approximately 9.8, 9.86 gets cancelled, and 4 gets cancelled. Nearly equal to how much? 1. The length is how much? 1 meter. Therefore, length of the pendulum is how much? 1 meter. What is the answer? The length of the pendulum is 1 meter. Another simple pendulum attachment chances are there. This question, observe once. Calculate the change in length of a simple pendulum of length 1 meter when its period of oscillation changes from 2 seconds to 1.5 seconds. Here, first of all, given data we have to write. In this, what they given? Given simple pendulum of length. Initial length is given, L1 value is given. How much given? 1 meter. And what they given? Time periods also given. What they given? Time periods T1 is given 2 seconds and T2 is given 1.5 seconds. Here what they are asking, change in length. First we have to calculate the L2 value. Then we have to find the change in length. Change in length L1 minus L2 value we have to calculate. Change in length L1 minus L2 value we have to calculate. Same simple pendulum only. Time period formula is what? From simple pendulum time period formula, T equal to, what is the formula? Just now we discussed. What is the formula? 2 pi into under root L by G. Here the length and time period comparisons. So that is why what I'll do, the T is directly proportional to T and length. What are the relation T is directly proportional to the root L. T is directly proportional to what here? Root L. Squaring on both the sides, same like that only. What happened? T square is directly proportional to L. We need to calculate first L2. So that is why L2 by L1. L2 by L1 equal to what? T2 square by T1 square. T2 square by T1 square. L2 by L1 is equal to L2 by L1. L1 value is how much? 1 meter, 1 only. And T2 square. T2 is how much? 1.5 whole square by T1 square is 2 square. T1 is how much? 2 square. That implies 1.5 whole square. 15 whole square is, we know that, 225. Here decimal is there. That is why 2.25. 1.5 whole square is what? Solve that one. 1.5 into 1.5. You will get 2.25. Divided by 2 square is how much? 4. Solve this one. 4 1 ja. Here decimal is there. 4 5 ja 20. Again here 2 is there. 4 6 ja 24. Again here 1 is there. So 4 2 ja 8 and 4 5 ja 10. 0.5625 meters. L2 value how much? L2 is 0.5625 meters. Okay. Now change in length we have to calculate. What to calculate? Now change in length. Therefore change in length is equal to L1 minus L2. That equal to what? L1 is 1 minus 0.5625. 1 minus 0.5625. So like this, 1.001 means what? And 0.5625, solve this one. 10 minus 5 is what? 5. 9 minus 2, 7. 9 minus 6, 3. 9 minus 5, 4. Here 0. 4375. Therefore, change in length L1 minus L2 value is how much? 0.4375 meters. This is the answer. This type of problems they can ask in the attachment problems. So here my previous students, number of students got 60 by 60 in physics by following very easy methods, long answers, short answers and very short answers. By easy method they learned. So that is why they got the marks. So I hope you also get the 60 by 60 in physics, intermediate first year physics. So this give the boost to your second year physics. First year if you get 60 by 60, the second year, so with more encouragement will be there, so you'll get more marks in the second year physics also. And not only this, the remaining all LAQs, so I am explaining in upcoming classes, so please follow that. First year, second year, whatever the physics, MSET, okay, JEE mains and NEET, especially NEET, so you can observe the all classes. Please subscribe the video. I hope all are understood by easy method. Inform to your friends, share to your friends. It may helpful to your friends also. Thank you so much. This is Ramana sir, physics.